Welcome back to my channel. In today's video, we're going to explore the fascinating world of massive stars and their evolution into Wolf-Rayet stars. As you may know, these stars have a relatively short lifespan compared to other types of stars. But what causes this and what happens to them during their evolution? We'll start by looking at the basic structure and life cycle of massive stars, and how they differ from smaller stars. Then we'll dive into the specific evolution of these stars into Wolf-Rayet stars, which are known for their extreme temperatures and strong stellar winds. But our focus today will be on one particular Wolf-Rayet star, WR124. This star is located in the constellation Sagitta, and it's one of the brightest and most massive stars in our galaxy. We'll explore the unique features of this star, including its high mass loss rate and the implications this has for its future evolution. So join me as we journey through the cosmos to learn more about the fascinating world of Wolf-Rayet stars, and why WR124 is such an important star in our galaxy. Let's get started. Wolf-Rayet stars are a fascinating type of star that are characterized by their extremely high temperatures and luminosities, as well as their strong stellar winds. They are named after the two French astronomers who first identified them, Charles Wolf and Georges Rayet, in the mid-19th century. One of the key characteristics of Wolf-Rayet stars is their short lifespan. These stars are massive, typically having a mass of 20 to 30 times that of the Sun, but they burn through their fuel at an incredibly fast rate. As a result, they only have a lifespan of a few 100,000 years, which is very short in astronomical terms. As they evolve, Wolf-Rayet stars shed their outer layers of gas, which creates a strong stellar wind that can reach speeds of up to several thousand kilometers per second. This process exposes the star's hot, inner core, which causes it to emit intense ultraviolet radiation and X-rays. Another notable characteristic of Wolf-Rayet stars is their chemical composition. These stars are highly enriched in helium and nitrogen, which is thought to be a result of nuclear reactions taking place in the star's core. They also contain trace amounts of heavier elements such as carbon, oxygen, and silicon. One of the most famous Wolf-Rayet stars is WR124, which is located in the constellation Sagitta, around 8,000 light-years away from Earth. WR124 is particularly significant because it is one of the brightest and most massive Wolf-Rayet stars known to exist. It has a mass of around 25 times that of the Sun and is thought to be around 200,000 years old. Despite their relatively short lifespan, Wolf-Rayet stars play an important role in the evolution of galaxies. Their strong stellar winds and intense radiation can have a significant impact on the surrounding interstellar medium, triggering the formation of new stars and influencing the chemical composition of the galaxy as a whole. Wolf-Rayet stars are some of the most fascinating objects in the universe, characterized by their short lifespan, intense radiation, and strong stellar winds. By studying these stars, astronomers can gain valuable insights into the processes that drive the evolution of galaxies, as well as the physics of the most extreme objects in the universe. WR124 is one of the most interesting Wolf-Rayet stars in our galaxy, and it's located about 15,000 light-years from us in the constellation Sagitta. This star is not only interesting because of its enormous size and brightness, but also because it's surrounded by a massive and complex nebula known as M1-67. M1-67 is an enormous and beautiful nebula, measuring about 6 light-years across and estimated to be around 20,000 years old. It's a bright and colorful object, featuring intricate patterns and shapes that have been shaped by the winds and radiation from the star at its center. This nebula is a prime example of the kind of complex structures that can be formed around massive stars, and it's helped astronomers learn a great deal about the evolution and behavior of these fascinating objects. One of the most striking features of M1-67 is its distinct hourglass shape, which is caused by the outflow of material from the star. This material is ionized by the intense radiation emitted by the star, creating a bright and colorful display. The nebula is also home to a number of smaller filaments and structures, which are thought to have been shaped by the winds and outflows from the star over time. Overall, WR124 and M1-67 are an incredible example of the beauty and complexity of our universe. These objects are a testament to the incredible power of massive stars, and they're helping us to better understand the processes that shape our cosmos. The James Webb Space Telescope, also known as JWST, is set to launch in 2021 and is expected to revolutionize our understanding of the universe. One of its primary goals is to study the formation and evolution of galaxies, stars, and planetary systems. JWST is equipped with infrared cameras and spectrographs that will enable it to observe the universe in greater detail than ever before. It will be able to see through the thick clouds of gas and dust that surround many stars, providing a clearer view of the star and its surroundings. This is especially exciting when it comes to Wolf-Rayet stars like WR124, which are surrounded by dense nebulae. JWST's infrared capabilities will allow astronomers to study the star and its nebula in unprecedented detail, providing insights into their formation and evolution. The telescope will also be able to study the chemical composition of the nebula, which can reveal important information about the star's past. By analyzing the composition of the nebula, astronomers can learn about the star's previous stages of evolution and the processes that led to the creation of the nebula. In addition, JWST will be able to detect the presence of molecules in the nebula, such as water and carbon monoxide. These molecules can reveal important information about the physical conditions in the nebula and the processes that are ongoing within it. Overall, the James Webb Space Telescope's infrared observing capability is poised to provide groundbreaking insights into the nature of Wolf-Rayet stars like WR124 and their surrounding nebulae. It represents a significant step forward in our understanding of the universe and the processes that shape it. Wolf-Rayet stars are known for their extreme stellar winds, which can blow at speeds of up to millions of miles per hour. These winds are caused by the star's intense radiation, which pushes out material from the star's surface. In the case of WR124, the star's winds are so strong that they collide with the surrounding interstellar gas and dust, creating a shockwave that heats up the gas to millions of degrees, causing it to emit light in the form of a glowing nebula. The nebula surrounding WR124, M1-67, is about 6 light-years across and 20,000 years old. It is a beautiful and complex structure, shaped by the interplay of the star's winds and the surrounding environment. With the upcoming launch of the James Webb Space Telescope, astronomers hope to learn even more about WR124 and its nebula. The telescope's infrared observing capability will allow us to see through the dusty regions surrounding the star, giving us a clearer picture of the star's properties and the structure of the nebula. Overall, WR124 and its nebula are a fascinating object for astronomers to study, and with new technologies like the James Webb Space Telescope, we will be able to uncover even more about the secrets of these massive stars and their role in shaping the universe around us. Previous observations of WR124 and its nebula have been conducted by other telescopes as well. In 2015, the Herschel Space Telescope was used to capture far-infrared images of the nebula, which revealed the presence of cold dust clouds within it. In addition, the telescope's observations also indicated the presence of ionized carbon and nitrogen gas in the nebula. The Very Large Array, a radio telescope located in New Mexico, was also used to observe WR124 and its nebula. The telescope's observations revealed the presence of 2 arcs of radio emission coming from the star, which were interpreted as shock waves caused by the collision of the star's stellar wind with the surrounding material. These previous observations provide valuable insights into the nature of WR124 and its nebula, and have helped to refine our understanding of the star's evolution and its impact on its surroundings. However, the James Webb Space Telescope's infrared observing capability is expected to provide even more detailed and comprehensive data, which will help to unlock many of the mysteries surrounding this fascinating star and its nebula. Another interesting aspect of WR124 and its surroundings is the cavities in the gas surrounding the star. These cavities are essentially empty regions in the gas where the density is lower than in the surrounding regions. They are created by the intense stellar winds that blow out from the star at incredibly high speeds. What's unique about WR124's cavities is their unusual arrangement. They are not uniformly distributed around the star, but instead, they are elongated and oriented in the direction of the star's motion through space. This is likely due to the fact that WR124 is moving at a high velocity through the interstellar medium, causing its stellar winds to be deflected in a specific direction. This unusual arrangement of the cavities was first discovered by the Herschel Space Telescope, which observed the nebula in the far infrared. The observation revealed that the cavities were filled with hot gas, which was heating up the surrounding gas and causing it to emit in the infrared. More recently, the Very Large Array, a radio observatory, observed WR-124 and its surroundings in radio waves. This observation revealed that the cavities were also filled with ionized gas, which was emitting radio waves. This is a testament to the power of combining observations from different telescopes to gain a more complete understanding of astronomical objects like WR-124 and its nebula. WR-124 has a significant role in the universe's dust budget. Cosmic dust is an important component of the interstellar medium and plays a crucial role in star formation. The dust in the interstellar medium is produced by stars like WR-124, which have high mass loss rates and produce a large amount of dust in their stellar winds. The dust produced by WR-124 and other stars is eventually recycled into new generations of stars, contributing to the cosmic dust budget. This dust also plays a critical role in the formation of planets, including the Earth. The dust particles act as building blocks for the formation of planets, and without them, planets like Earth could not have formed. So the study of WR-124 and its role in the production of cosmic dust is critical to our understanding of the universe's evolution and the formation of new stars and planets. The James Webb Space Telescope's observations of WR-124 and its surroundings will provide us with valuable insights into the role of massive stars in the production of cosmic dust and the formation of new stars and planets. In conclusion, WR-124 and its nebula, M1-67, play a critical role in our understanding of the universe's dust budget and the evolution of massive stars. The unique characteristics of this star, such as its extreme stellar winds and rapid velocity through space, contribute to the creation of the beautiful and complex nebula. The James Webb Space Telescope's infrared observing capability presents an opportunity to capture more details about this star and its surroundings. It is exciting to think about what new information we will learn about this star and other rare celestial events with the help of the JWST. By studying objects like WR-124 and its nebula, we can further our understanding of the universe and its formation. The more we learn, the more we can appreciate the beauty and complexity of the cosmos.